In section 7.4, we're looking at the sum to product and product to sum identities that we're going to derive. In order to do these derivations, we're going to start with the identity that the cosine of alpha minus beta is cos alpha cos beta plus sine alpha sine beta, and the plus version of this, the cosine of alpha plus beta, is cos alpha cos beta minus sine alpha sine beta. And I notice simply if I were to add these two equations together, that on the left-hand side I'll have cosine of alpha plus beta plus the cosine of alpha the cosine of alpha minus beta plus the cosine of alpha plus beta occurring. And on the right-hand side, if I add these two together, these two will cancel each other, leaving me simply this twice. Now, if you divide both sides by 2, you get that the cosine of alpha cosine of beta is equal to 1/2 of this expression here. And this is called the product to sum identity for the product of two cosines. Okay? Similarly, if I start with the identities for sine, the sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta, and the sine of alpha minus beta is sine alpha cos beta minus cos alpha sine beta, and I add these two together. On the left, I'm adding these two terms. On the right, when I add these two terms, it's the cosine times the sine that cancel each other here, leaving me with two versions of this. Again, if I divide both sides by 2, I get this expression that tells me how the product of a sine and a cosine becomes the sum of two sines instead. Now, if I go back to the cosine expression up here, and instead of adding these two equations together, I were to subtract the two equations, so this minus this is this minus this, then these cosines here are going to be the ones that cancel, and I'll get two versions of this, minus of a negative becoming a positive, giving us this expression here. Okay, and again, if I divide by a 2, or in other words multiply by 1/2, I get the product of two sines, becoming 1/2 the cosine of alpha minus beta minus the cosine of alpha plus beta. All right, now let's take a look at how we'd apply these to a problem. In exercise 6, I have 20 times the cosine of 36t times the cosine of 6t. I want to apply my identity to this. So I'm taking the identity for the product of two cosines. That's up here. Cosine times a cosine is 1/2 the cosine of the difference of the angles plus the cosine of the sum of the angles. So the 20 in front times the identity for 1/2 cosine of the difference of the two angles plus cosine of the sum of the two angles, and that simplifies to this expression. And that's the rewrite we were after as our answer. Similarly, in problem number 10, I've got a sine times a cosine. So I go to my identity up here for the sine times the cosine. It's going to be 1/2 the sine of the sum of the two angles plus the sine of the difference of the two angles. So 1/2 the sine of the sum of the two angles plus the sine of the difference of the two angles. And I rewrite that to this form. Now notice here you have the sine of negative 2x. Typically, when we have a negative on our argument, whether it's a sine or a cosine, we use the property of the sine or the cosine to resolve that negative. Remember, sine is the function that spits its negative out in front. So that means that negative can come out in front. You have negative the sine of 2x. Had this been a cosine, the cosine would have consumed that negative, and it would have merely been the cosine of 2x appearing there. Okay. All right. Now, another example. Take a look at problem number 18, where we have the product of cosine and sine occurring here. So again, the product of a cosine and a sine. Excuse me. That's the same as a product of a sine and a cosine. So I'm using this identity. The product of a cosine and a sine is 1/2 the sine of the sum of the two angles and the sine of the difference of the two angles. And that plays out this way as I plug in the numbers. Okay. Simplifying the numbers, and again, when you have a negative on the argument, using the property of the sine that spits that negative out in front, I get this. Now evaluating the sine of 60 degrees and the sine of 30 degrees gives me these numbers. And if I simplify this, writing it as a single fraction, it's root 3 minus 1 over 4, and we're done with the problem. Another example. cosine of 23 degrees times sine of 17 degrees. Very similar to problem number 18, a product of a cosine and a sine. So you're using the same identity. The one difference here is that when I resolve these, 17 degrees plus 23 degrees gives me 30 degrees. That I'll be able to evaluate. Here, 17 degrees minus 23 degrees gives me negative 5 degrees. I will not be able to evaluate the sign there. So my final answer, I pull out the minus, I leave it like that. I don't try to do the evaluation, okay? All right. Let's move on to now deriving the sum to product formulas. And we do that by using a substitution into those product to sum formulas that we just derived. The substitutions we're going to use are the following. We're going to replace the angle alpha with the expression u plus v over 2. And we're going to replace the angle beta with the expression u minus v over 2. Now the purpose of this can be seen when we note the fact that if I add alpha plus beta, the u plus v over 2 and the u minus v over 2, they simplify down to u, right? When you add these together, common denominator, the v and the negative v cancel, you get 2u over 2, which is u. Similarly, if I were to subtract alpha minus beta, u minus u, those are going to cancel. V minus a negative v will give you 2v over 2 is just v. And of course, the alpha plus beta and alpha minus beta forms, that's what we see in these previous identities. So when I look at this identity that we've derived before, the product of a sine and a cosine, and I replace alpha with u plus v over 2 and beta with u minus v over 2, the alpha plus beta is going to become u, and the alpha minus beta is going to become a v, and it gets rewritten this way. If I now multiply both sides by a 2 to get rid of this half here, I get the sum of a sine and a sine becoming the product of a sine and a cosine in this form. Okay? If instead I had started with the identity cosine times cosine instead of sine times cosine, okay, and I substitute into this, right? This is going to be my v, the alpha minus beta. This is going to be my u, the alpha plus beta. And over here, I'm going to have the alpha plus beta over 2 and the alpha minus beta over 2. I'm sorry, the u plus v over 2 and the u minus v over 2 occurring. Again, multiply by a 2. And now we see that the sum of two cosines becomes the product of two cosines with this identity. Okay? If I do a similar thing, I can get this work for the cosine of the difference of two angles, the cosine of u minus the cosine of v, being the product of two sines, and the difference of two sines being the product of a sine and a cosine. Similar same substitutions into the identities that we derived prior. Okay? All right. Now let's take a look at how we use these. In problem 28, I have the cosine of 58 degrees minus the cosine of 12 degrees. That's where we're referring back to this identity, cos minus cosine. It's going to be a minus 2 sine of u plus v over 2, sine u minus v over 2. So minus 2 sine of the sum of the two angles over 2 times sine of the difference of the two angles over 2. I simplify that down. I get minus 2, the sine of 35 degrees, and the sine of 23 degrees. And now these are not special angles that I can resolve, so we stop there and we say that's our final answer. In problem 46, we're asked to prove an identity. This will be the last problem we look at in this section. The identity that we're given is sine of 3x minus sine of 5x divided by cos 3x plus cosine of 5x is said to be the same as the tangent of x. And in fact, the question here is this really an identity or is it not? And so we're going to go through the work, applying the identity for the sine of the difference of two, sine minus the sine here. We get 2 sine of 3x minus 5x over 2 times cosine of 3x plus 5x over 2. For the cosine plus the cosine identity that we just derived, we get 2 times the cosine of 3x plus 5x over 2 times the cosine of 3x minus 5x over 2. Now notice, of course, you have a 2 in the top and a 2 in the bottom. Those can certainly cancel. You also have a cosine of 3x plus 5x over 2 in the top right here, and a cosine of 3x plus 5x over 2 in the bottom right here. Those are factors that can cancel as well. So what I'm left with in the top is sine of 3x minus 5x over 2, and in the bottom, cosine of 3x minus 5x over 2. And again, we're claiming that's the same as the tangent. So now when I simplify this, 3x minus 5x is a negative 2x. Divide that by 2, you get the negative x as the argument of this sine. Same thing here, 3x minus 5x over 2 simplifies to negative x. If I then apply what a sine function does to its negative, it spits the negative out in front. What a cosine does is it consumes its negative. I'm going to get negative sine of x over cosine of x. And the question is that tangent? Well, negative sine of x over cosine of x is in fact the negative of the tangent of x. So this result is that the negative of tangent of x is what you have on the left. The positive of tangent of x is what you have on the right. They're not equal to each other. This is not an identity. Okay? All right, so give these homework problems a try. See if you can apply these new identities to solving some of these problems and proving or disproving some of these identities. And as always, if you have any questions or concerns, communicate with me. Let's see what problems you need to see worked out carefully. You can always put up a little video to show a couple of problems if you wish. All right, I look forward to hearing from you, and good luck with the studies.